You're probably aware of the async changes that are coming to Zig in the near future, not 015, but sometime soon. And you might have a lot of questions. I did too. Thankfully, I had a really awesome opportunity to talk to Loris Cro, the VP of Community at the Zig Software Foundation. I recorded our entire chat. The chat will have minimal editing, and I'm just going to play it for you here. We cover all sorts of topics about I/O, async, concurrency, parallelism, what they mean. We talk about a couple other things a little off topic. Every good conversation goes off topic every now and again. And we talk a little bit about Loris's role at the Zig Software Foundation. So hopefully you enjoy the conversation as much as I enjoyed having that conversation. We talk about a ton, so I will put links in the description for every single thing we talk about. So if you want to follow up on any of Loris's blog posts or really anything we talk about, I'll make sure to have a link in the description. Let's get to it. Well, thank you for taking the time to chat with me today. I have a ton to talk to you about, but mostly we want to talk about the new async model and I/O. I have to imagine more people know who you are than they know who I am, but do you want to take a moment and introduce yourself anyways?
Sure. So I'm Loris Cro. I'm VP of Community at the Zig Software Foundation, and that's mostly it. And I have a static site generator, Zine. That's it.
Yeah, I've watched some of the streams where you've worked on that and asked a ton of questions. Specifically, one that you really helped me with, I asked about built-ins and how to know when there is a built-in that you can reach for, because that was one of the things that about when I started messing with Zig maybe 7 or 8 months ago now, I really started to struggle with was like, I would implement something and then I would realize that there was a built-in that solved that problem. And, I asked you about that. You had some great feedback, which was more or less you look through them ahead of time and try to identify the ones that you might commonly need. But yeah, cool. So how long have you been, let's start with writing Zig, just to put some perspective on things.
So I got involved with Zig, I think around version 0.4, maybe. I don't remember specifically. 0.3, 0.4, I think around that time. More specifically, this was before the Zig Software Foundation was a thing. So Andrew at the time was still working on Zig part-time. And then I became part of the Zig Software Foundation as soon as it was founded, like I was the first employee.
Awesome. So that sounds cool yet terrifying. I'm not sure what you were doing beforehand, but I've had an opportunity to join like a really early startup, and that idea sounds terrifying. And then when you throw a nonprofit foundation on there in front of that, it sounds even more terrifying.
Oh yeah. So I have a funny story about this. So also I just realized I didn't give you like a time range. I think this was about 5 years ago? No, more than that, maybe. Let's say 6 years ago, between 6 and 7, I think. So when Andrew suggested that I would join the Zig Software Foundation, the idea was that at the time he did not have enough donations to pay 2 salaries. So he said, I have some money saved in the bank that I'm willing to use and invest into, let's say, this experiment. So your first job is going to be to get us enough donations to pay both of our salaries. And if you can do it before that money runs out, great. Otherwise, the experiment will have not worked out. So right from the bat, it was like kind of a jump in the dark. But it did work out in the end.
Yeah, and I'm very grateful that it did. So in that sense, it sounds like you do fundraising for the Zig Software Foundation as well. Is that correct?
Yes and no. So the job description is to increase the total amount of effort being spent on Zig. And that does cover money, because if you have money, then you can pay developers core contributors to actually work full-time on Zig. But then there's also other aspects about community building, because having a bigger community, like a more vibrant community, helps with having, at the end of the day, more effort being spent on Zig, on the Zig project. The money part is certainly one of the things that I do, but I would say I wouldn't consider it the main thing that I do, because I think in reality, given the nature of the project, it's hard to chase donors. We have some donations, but they mostly come from entities and individuals willingly donating this. I think that if I focused entirely, like everything that I do, on fundraising, I would probably be able to scrap together more donations than what we currently have. But I don't think it would be a big difference, and I think I would start hitting some, diminishing returns very quickly.
Well, it seems like a lot of what you do is also around adoption for Zig. And in theory, the more people that adopt Zig, the better chances we have of people loving it and donating. So there's a cycle, right? So you've done some open source stuff. You did your operating system in 4 days in Zig post, I believe. Just some of the things that have stuck out to me. So that makes sense that chasing donors probably isn't the best avenue to really pursue Zig's mission.
Yeah, and I would say in part is also because of like personal disposition. I think that I think you would need somebody with probably a different personality to really be effective at that, as in like chasing potential donors and like somehow making it work, convince companies that aren't really all that interested in Zig to somehow jump on board and convince them to donate to open source. I don't really do that kind of stuff. But I think I'm capable to interact with people and companies that do have a genuine interest in Zig, but past that, yeah, it's hard. And the community aspect does have also a huge impact. That is for sure. If you want an example, the static site generator that I'm working on is something that I am opinionated about. So it's something that I feel like it's a form of self-expression, if you will. I've had experience with other static site generators. I made a bunch of static sites, so I'm happy to have my take on what I think static site generation should look like, at least for me. But at the same time, it's a project that is designed to work as a force multiplier for the community. The idea is that the community has projects, and there are projects that don't have websites that explain really well what the project is capable of doing, like the level of maturity, etc. And so I wanted to have basically a solution in Zig that was, featureful enough and like fast enough so that I could point people into the community and say, look, you have a nice project. Please make a website for it, because making a website is how you make your project known.
Yeah, that's interesting. That makes a lot of sense. That's funny. I was talking to a friend yesterday, actually. I was looking at RSS parsing options in Zig, and one of the things that always comes to mind is just use something in C. And I stumbled upon a C library for RSS parsing where the README was one line, and it didn't even mention the project's name. And like, that's not really helpful. But I looked for a site as well, and none of that information. So that makes sense, and I'm glad to see that you're focusing on that effort. That seems very, very useful. I'd be happy to jump into the I/O stuff and the async stuff if you don't mind. I've looked through your posts, your two most recent concurrency posts, and I'm very excited that async is coming back to Zig. I do have some concerns, so I'm gonna pull that up in a tab really quick, just so I don't misspeak on anything. Specifically Zig's new async I/O. Okay, yeah, I have not written anything with the new I/O patterns yet, so I wanted to make sure that I was looking at proper code, and I am. So it's a part of the standard library, so we have standard I/O that we pull in. I love the idea that you can bring your own runtime. One of my gripes, actually, I have plenty of gripes with Rust, but Tokio is being one of my biggest gripes with Rust is that it's completely third party, and you bolt it on, and it just kind of somehow usually works. I like that we're keeping the explicitness that Zig has, but one of the things that I find a little difficult is that I/O will be passed around everywhere. So I have a Go background. I'm used to context being passed around everywhere. I really like what Odin does to solve that problem. However, I also hate that it's not explicit. So I have a bit of an identity crisis there, I guess. And I'm curious what patterns you expect to emerge where, like in Zig, everything is getting an allocator and maybe an IO and maybe some writer to handle logging or something like that. So like at some point you're passing all these things around, right? Is there dependency injection in mind at some point? What does that look like?
So in practice, I think your last example is the best practical perspective to start thinking about this stuff. So you said, you will want to pass IO, maybe an allocator, maybe some writer. You said for logging. Okay, let's get concrete about these things. So you will not have to pass IO for logging because logging is it's part of the standard library, and it has these, let's call it like a singleton style initialization. So it's like you have one global logging configuration, and then you can create specific loggers for scopes, but they all quote unquote inherit the global configuration that you do at program startup. So the idea is that in your main function, you will configure your logger to use IO, like a specific implementation of IO. And then basically you will still be able to do std.log, .info.debug, and you can just print that way to your logging without needing to have a reference to IO available in the current scope. So that is not necessary. Related to this, there's also a proposal titled Juicy Main, where basically the idea is to have the main function in Zig also do more initialization for you. I'm not going to get too much into it, but basically the idea is to have the main function. You basically say that your main function accepts a init parameter, and if your function, if you define main to accept an init parameter, then you know how right now you can already have a main function that can return just void or maybe an error, and if it returns an error, then Zig will automatically print the stack trace. So this is basically some glue code that exists between the entry point at the OS level and your main function. So the idea is that this glue code will also provide you with initialization, automated initialization for things if you ask for it. One of which is going to be also automated initialization of logging in the standard library. Okay, so logging is fine. Similarly to logging, also std_debug.print will not require IO. So if you just need to throw a debug print somewhere, you can do it without any ceremony. Readers and writers. You do not need a reference to IO if all you're doing is reading or writing a stream. More specifically, I have a Redis client. And my Redis client, right now, as it's written, only concerns itself with reading and writing on a connection. It doesn't try to do, like, if the connection breaks, it doesn't try to restart the connection. I'm not saying that this is how it should be. I'm just saying this is how it is right now.
Sure.
So for this type of program, of struct type, let's say library. For this type of library, since it only concerns itself with reading and writing to a stream, then it doesn't need a handle to IO because the readers and writers will bundle that reference. Let me explain a little bit more what I mean by that. So when you write a parser, you can write a parser mainly in two styles. One is you assume that you have everything that you're parsing in memory, and it's a slice, and you index into the slice. Or you assume that what you're parsing is a stream. So you pull from the stream, you consume content from the stream. If you have the first kind, the one that assumes that everything is available in memory as a slice, then you have the problem that you need to first read everything and then pass everything to the parser. And sometimes that depending on the protocol, that's not even something realistic that you can do. So generally speaking, it's preferable to structure a parser as something that reads bytes from a stream. But here's the thing. When you have a parser that reads bytes from a stream, this stream could actually be a real connection, like a real socket or a real file. But you can also create a reader that provides a reader interface to a slice that you have in memory. So while it's not really feasible to basically have a parser that assumes a slice, make it work with the network, the other version is actually much easier. So you can create readers and writers that don't read from a socket, but they actually read from a slicing memory or write to a slicing memory. So where am I going with this? The point is that reader and writer are not necessarily tied to I/O. They are two interfaces that could be connected to memory, so a reader that reads from a slicing memory, or they could be connected to I/O if they read from a socket. Long story short, code that only parses needs a reader or a writer, depending on what it wants to do, but it doesn't need I/O because it will be the reader interface that will bundle that or not, depending what is connected to. Okay, so we are good. So logging is good. Readers and writers are good. They don't need I/O. You will need I/O if you intend to instead do things like calling async functions. So for example, you want to call things in a asynchronous way, then you will need access to I/O. If you want to do direct printing to standard out, for example, in the sense that you don't only accept a reader, but you also want to, you yourself, get a handle to standard out and do something with standard out, or like open files, for example. If you want to open files, then yes, you will need access to the I/O instance. I think it's not going to be too bad. And you will have the neat side effect that you will be able to see more at a glance what a function concerns itself with, roughly speaking. It's not going to be surgical, like it's not going to be like Haskell where you have, I don't know, the I/O monad and whatnot. But you will be able to say, oh, okay, so this function, for example, this function doesn't accept neither an allocator nor I/O nor any kind of reader. This is probably a function that just does math on memory, like computes something in memory. It accepts an allocator, so it does something in memory, but it also needs to grow memory potentially. If it accepts I/O instead, this is probably a function that has side effects, roughly speaking.
Yeah, that makes sense. Have you read Bob Nordstrom's "What's the Color of Your Function" blog post?
Yes.
Okay. Yeah. I guess so. Having I/O as the first parameter or allocator as the first parameter. Also, interesting nitpick. Which one should be first now? Because the convention has always been that the allocator is first, right?
Yeah, I can tell you that so far the consensus in the core team is that I/O should go first.
Okay.
At least me and MATLAB are two big proponents of that perspective. I don't know. Actually, I don't know what Andrew thinks about this, and I don't know about the others, but I/O seems even more fundamental than allocator.
Yeah, I think it would be nicer to when scanning to see I/O first to identify what is potentially asynchronous. So thinking about those functions like that. And also on that note, I just mentioned the words potentially asynchronous. So one of the things that I saw is that the standard library is going to ship with some implementations. And one of them is just a blocking I/O, right? So if you wanted to just to get started out of the box, and maybe you haven't thought about how things should work asynchronously, hopefully you have, but you could run everything synchronously using one of the synchronous runtime, right?
Yes, and there's also another perspective behind this. The idea is that while it is nice to have access to an event loop and all the fancy non-blocking stuff, this is extra machinery that you are pulling into your executable. And if you need it, then obviously you want it, so fine. But the idea is that we should not regress the case where you just want to do symbol blocking I/O. So like, in a sense, we don't want to regress Hello World as an example. Mm-hmm. Because if we didn't have any simple blocking, single-threaded, like non-thread pool version of I/O, then your Hello World would always have to spin up, a new thread and do all this extra work that is absolutely not necessary.
Yeah, that makes total sense. I was curious about that, and reducing the file size of your executable makes total sense. I've been doing a lot of, we'll say, exploratory stuff in WASM with Zig, and I was curious how I/O would work in that case, but I would assume you would just use the blocking I/O runtime, since thread pools aren't really supported.
Yes. So I think there are let me think, 2 answers and a half in here. So okay, there are two main things that you have to worry about. One is task switching, and the other one is non-blocking I/O. So on one hand, you need to be able to issue writes and reads over to a file descriptor and not get stuck there. So WASM, in that sense, well, WASM itself doesn't care about that. That's more of a WASI thing. So WASI, as far as I know, only has support for poll, which is not great. It's an API that you also have on Linux, and it's considered just not good. All right, you know what? No, maybe I'm being too harsh, but let's just say it's not what people use preferably for serious evented I/O. So you have that API in WASI, but it's, how can I say, you don't have all the capabilities of, I don't know, I/O ORing, for example. So there is something to be kept in mind. Then you have the second problem, task switching. How do you task switch? Yes, you don't have threads, so you can't task switch with threads. If you have support for coroutines, stackless coroutines, which is what people normally think of when they say async await, if you have support for that, then you can use that to task switch. But Zig currently does not have that yet. There is a proposal to add support for stackless coroutines again in the language, because we used to have them. They got removed. But so far, it seems that they will come back. So unless a big blocker is found at the implementation level, they should totally be able to come back. So once we will have them, we will be able to use that. Finally, there is a proposal for WASM to add support for green threads. So not real OS threads, the switch, but userland inside of WASM stacks that you can switch, that you can schedule for execution or like unschedule. And if that proposal is accepted, then we will be able also to use our green threads implementation of I/O.
And that proposal is dependent. Excuse me. That proposal is dependent on reintroducing, like I think it said new function calling conventions or something very new, right? Or different than the way it works currently. The stackless coroutines.
You're talking about stackless coroutines in Zig, right?
Yes.
Yes, it used to be a calling convention. I don't know if it will be. It might not be. But I would say the calling convention is one, I think, good way of thinking about this problem. But it's also a implementation detail of Zig, like the concept of having calling conventions and how they're purposed in Zig. That's like a Zig thing. So I guess my point is, let's reason now about calling conventions, but be aware that then this mechanism might change, might not be actually a calling convention, might be something different. That is up to basically who is going to design this stuff. More or less, it's up to what MLAG decides to put in his proposal and what the final design ends up being. But in the meantime, yes, the idea is this. When you have threads, so let's talk about OS threads. When you have OS threads and you want to task switch, you don't have to do pretty much anything. You need non-blocking I/O because you need to be able to say, please OS, read this or write this. But then you need to be able to regain control. You cannot be stopped there by the OS. Otherwise, there's nothing you can do. So once you have that, then you want to be able to say, okay, I'm now waiting for this I/O operation to complete. I want to stop executing this function because this thread, because we are waiting for the result to come. And so you can yield the thread. Green threads are very similar. In green threads, you do something almost identical. The difference is that you take on some of the duty that the OS would otherwise, some of the things that the OS would otherwise do for you. And this ties back to what I was implementing in operative system in 1,000 lines of code that you mentioned earlier. Because in that book, you learn how to do task switching. Like you learn from the perspective of the OS what it means to schedule a thread on a CPU and like take away one thread from the CPU and place there another. And that same thing, like almost one-to-one, is what you do with green threads. So with green threads, you have to write assembly code in your function that copies the current state of the CPU of every register, saves it somewhere in memory, and then changes the register of the current stack to another stack, and copies also restores basically a snapshot that was previously made of the other state of the CPU, in that way, once you do this, the CPU will start executing the other green thread, exactly like you do with OS threads. The only difference is that the switching operation is done by you, not by the OS. So in both these cases, your code doesn't have to change. Aside from the magic assembly to take a snapshot of the CPU and restore it, etc., everything else can stay the same. With Stackless Coroutines, it's much more complicated, because with Stackless Coroutines, basically, everything that calls an async function, I'm being slightly imprecise, but for simplicity, let's say that everything that calls an async function needs to be transformed into a switch case, where every time you block on something, every time you would block on something, instead of blocking, you return from the function that has been turned into a switch case, and internally the function saves that the next time it gets invoked, it should start from another branch in the switch case. And basically your function becomes like multiple stages in a switch case. This is like one way of implementing it. There's also different ways, but conceptually it's this idea that your function has to be transformed. And this transformation is done for you by the compiler. This has viral consequences, because when the async function, a function that is async needs to be turned into this, but then if it gets called by another function, the function that calls it also in turn has to be turned into this kind of thing. And so this has, as I was saying, like a viral nature. And in Zig, we used to express this idea as a calling convention.
Interesting. Wow, that is a lot.
Yeah,
and a lot I did not know too. So thank you for explaining that. It almost sounds like your function ends up into like a function state machine type approach. Yeah, that's
yes. Those things are called coroutines. And they're also, or like sometimes also generators. Like these things are very related. Have you ever used a generator in Python, for example, or similar languages?
Use them in JavaScript, yeah.
Okay, so you know the idea of the generator is that you can do yield, and it's kind of like return, but you also don't lose the state of the function, right?
Yep.
That's entirely the same concept, with the only difference that whenever you yield, you also yield a value. While normally an async function doesn't yield intermediate values, it blocks execution, it returns control to the caller, but then you only collect a return value when everything is done, like at the very end. And that's usually what you call the promise or the future.
Interesting. Okay. Yeah, I could see how you could start to hand roll something not nearly as complete, but with close to that with JavaScript and generators or something along that line. That's man, that is cool. Yeah, thank you. I should mention, just for my background, I don't have systems programming experience outside of Zig. Mm-hmm. Zig was my first time getting that low. I tried to do C, and that's actually what led me to Zig. I was like, this seems miserable. There's got to be a better option. And I found Zig and really haven't looked back. I had messed around with Rust a couple years ago, not for anything really low level. So my knowledge of like how everything works at a really low level is pretty minimal at this point. Mostly because I just haven't had experience working with that type of stuff.
Makes sense. Well, technically, I'm a bioinformatician, and Zig has been my main, not strictly the only, but my main way of learning about systems programming as well.
Oh, cool. Well, I'm glad to hear that. Hopefully, it'll be just as fruitful for me as it has been for you. So the second IO related blog post, or the asynchronous blog post, Asynchony is not concurrency. I had a question about that. Do you feel very passionate about that, or is that something that you're like needs to be mentioned for people to understand how IO works in Zig, and this is just the platform to mention it? It's the writing feels like you feel very passionate about the idea that asynchrony is not concurrency.
I would say that this has been kind of a discovery that we have made while working on Async IO. So I will give you an explanation of what I mean with these terms that hopefully you will find interesting. Also, by the way, we have been like workshopping definitions and like how to explain things over time. So hopefully, every time I do this, I get a little bit better. But so what happened is that since the first iteration of async awaiting Zig, it was possible to do this thing that other languages can't do, where you toggle async on and off. So I'm not going to, right now, I'm deliberately not using the new terminology. I'm using standard terminology. So when I say async, I mean async, in the general sense of, you have an async function in JavaScript or Python. In Python, so JavaScript is generally everything is kind of async, not strictly so, but mostly so. You don't really feel the pain, like the barrier between async and non-async in JavaScript. In Python, you feel it a lot. So in Python, stuff is not async by default, and once you opt into the async world, it's like two parallel dimensions. And you can't toggle it off, because you have, when you do def, async def, that's a async function, and it can't be non-async. And when you do await, you're calling await on something, and that thing needs to be awaitable. If it's not awaitable, then the await will cause you issues. And you can only call await inside of an async function in turn. So you have, because they do stackless coroutines, which are viral, and which require you to have that everything that does await needs to be async in turn. So with Zig, this was not. With Zig, this was better, because in Zig we were able to know, using comp time basically, to know if a function was awaiting something or not, and so we were able to toggle the calling convention automatically. In fact, in Zig, you don't use async in the function signature. You don't say this is an async function. You absolutely don't. You only use await inside of it, and then that makes the function async. Sorry, this is old Zig, not new Zig, the first iteration. So that meant that if you use the right switch that modified state in the standard library, you would be able to turn off all kinds of async. And that was neat, because it meant that you could write a single, let's say, database client. Like my Redis client at the time was able to work both in blocking mode and in async mode. I needed in the code to, in the database in the Redis client implementation, I needed to occasionally check if we were running in async mode or not, and do things slightly differently. But it was very minor stuff. The vast majority of it would switch transparently. Now, when we had this the first time, there was always this question of, well, but can I always toggle async off, and will my program work? And the answer was, well, in practice, the answer that we had at the time was, in practice, no. There are some situations where you call two async functions, and they need to progress concurrently. They need to make progress at the same time, roughly speaking. Otherwise, they will never complete. One example is, I made this server client example that maybe is a little bit too complicated. Let's make it even more minimalistic. You have one function that keeps checking for a global bool variable, waiting for it to flip. Maybe it's true, and it's waiting for it to become false. And so this is one function. And then you have a second function that, when running, flips that global boolean. So that means that the two need to make progress at the same time. You can't run the first one and then run the second one after the first one is done, because the first one will never be done until the second one also runs. So at the time, if you look at my by now very old blog post about the first iteration of async, my answer at the time was, no, you can't take any program and toggle off asyncness and be guaranteed that it will work, because of this example. So fast forward with this new iteration of async, and now that async doesn't imply anymore stackless coroutines, I reasoned about the problem space a little bit more, and we realized that now that the keyword async is not tied to stackless coroutines anymore, but it's a more general concept, it's a separate concept, then we realized that no, we can actually model correctly the presence or the absence of this relationship that I just described between two functions, whether they need to run at the same time for one to complete or whether they don't. And And that is why now we say asynchrony is not concurrency. Now, I give you the general idea. I have not given you the definitions for these things. So do you want me to go through those?
Yeah, if you don't mind, I think that would be helpful.
Yes. Okay, so here's the idea. I think the three big terms are asynchrony, concurrency, and parallelism. People have varying definitions for all these things. So the definitions that I'm going to give you are the ones that we use. They're not the definitions that other people use, but they are not completely incompatible. They're like I'm not making like up new definitions out of thin air. I think that the main reason why people tend to use slightly different definitions than us is because they have no reason to distinguish between concurrency and asynchrony, because for them, the async keyword implies stackless coroutines. And so it's like for them, I'll get to that in a moment, but for them, asynchrony is concurrency. It doesn't have to be. That's kind of the point. So, okay, let's start from the end. What is parallelism? For us, parallelism is the physical ability of a system to do multiple things at the same time, at the physical level. So it's the thing that basically means that it's basically CPU cores, for example. So the idea is you have to do n things. Doing n things in parallel takes the same time or close to doing one thing, right? So time to run, operation X takes time T. If you have parallelism, then you can do n times x, but it will still take the same amount of time because you have multiple cores and you run them truly in parallel. So this is parallelism, a time-saving thing. Concurrency is the ability of a system to task switch. So it's the ability to do a little bit of this, pause it, do a little bit of that, pause it, and come back to this. So threads, for example, are not a unit of parallelism. They are a unit of concurrency, because threads are what gets scheduled on a CPU core. In fact, a computer with a single CPU cannot do parallelism, at least when it comes to computation, because it only has one core. But it can do concurrency because it can task switch threads. Another way of doing task switching is green threads. You have OS threads that can task switch, and the OS does the save a snapshot of the CPU dense. But then green threads are a userland version of that. So it's kind of like a matryoshka a little bit. Like you're kind of doing almost the same thing, but like one layer nested deeper. So green threads are another form of concurrency because they are basically a unit of task switching. Stackless coroutines are also another way of doing that. Stackless coroutines work completely different than green threads. They do the function transformation into a switch case or callbacks or whatever that I mentioned earlier, but that also allows you to run a function up to a point. When the function yields, you regain control, and when you come back, you can continue from where you left off. So that's what enables task switching. Finally, what is asynchrony then? Asynchrony is a property of two functions where basically it means that they don't need to synchronize. So if two functions are doing completely separate things and their order doesn't matter one to another, then you can call them asynchronous. So for example, if you have a function that wants to save file A and another function that wants to save file B, if for your program it doesn't matter whether you save first file A or first file B, then you can say that these two function invocations are asynchronous because it's fine if the program completes them in any possible order. For you, it's still correct at the end of the day. Now, let's go back to the example of a function that is waiting for something else to flip a Boolean. Those two functions are not fully asynchronous because they literally need to synchronize. They need to synchronize over the Boolean flip. That's what makes them synchronize. So with this in mind, then in Zig, now here's what we do. When you want to say that when you're calling save file A and save file B, you use async. You use io.async because what you're saying is, yes, I would like for these two things to run concurrently, ideally in parallel if possible, if the system supports it, because order doesn't matter, and the faster you get it done, the better. But if the system cannot do that, if the system doesn't have multiple cores, and it doesn't even have task switching, actually having multiple cores at the end of the day, it doesn't matter. It doesn't make or break. It's just a matter of performance. But if your system doesn't support task switching which is the case when you have single-threaded blocking I/O, nothing else, you can still run them, and it's fine. You first save file A, and then you save file B, and it's still correct. It doesn't deadlock. But in the other case, where you have a function that is waiting for a Boolean to flip, that one cannot be run first that one completely, and then the second one, it will deadlock. So you use IO concurrent. IO concurrent means almost the same thing as IO async. All it does is say, you need to guarantee that you're running this function inside of a unit of task switching. So inside of a thread, inside of a green thread, inside of a stackless coroutine, because for correctness, for not deadlocking, we will need to task switch back to the caller function to continue execution. Otherwise, it will deadlock. So this way, by writing these different relationships between functions in the code, it means that when you try to turn off any kind of concurrency in a program, in a Zig program, if it has written correctly, so the idea is that when functions do need to synchronize with one another, run concurrently, but also synchronize, you use IOTA concurrency. If you did that correctly, then we are able to error out. We are able to say, sorry, this function cannot run in a context where there is no concurrency.
Okay, so quite a few thoughts. So going back to your definitions for a second. So by your definition of asynchrony, would you say that using mutexes in an asynchronous function no longer makes them synchronous? Or asynchronous, I should say, sorry.
Not as much. I would say that it's, I wouldn't think of it as a yes-no thing completely, because you can also have like you call an async function, but then at the end of the day, you want the result at some point, so you call a wait on it. So some synchronization has to happen. Also, for shutting off the program, you usually want to shut off the program once everything else is done. So you do want to synchronize, let's say, at the end, but they can complete execution without synchronizing with anything else. So if they have a mutex in the middle, yes, they are not fully asynchronous.
Okay.
And then it depends on what it is that's going to flip that mutex.
Yeah, I think I agree with that definition. I was just curious. That's the example that comes to mind when I think about asynchronous functions needing to wait on something would be, just a mutex blocking one of the executions. The second thing, so you mentioned IO concurrent or IO concurrency. Is it concurrent or concurrency?
Concurrent.
Okay, concurrent. So let's say I'm using the IO package. Most of my work will probably be with IO async and IO await, and then occasionally I might find myself in a situation where I need to use IO concurrent. Would that be a fair assessment?
I think so. I would even say that it's probably even better than this. I think that the majority of libraries will not have to concern themselves with any of this stuff at all. And then at the application level, you will start maybe composing things with async or concurrent, depending on your needs. And that will very rarely be the case that you do this as a library to be imported by somebody else. I'm not saying that this is going to be impossible, but I would say it's going to be very unlikely. And I think at that point, you are doing something that is like a use case that it's like big and structured well enough. Then basically, if you like, let's say that you're making like a web server that's meant to scale to, I don't know, hundreds of thousands of users, then of course you don't want to run that in single-threaded blocking mode. You will want to use a more lightweight server if that is your goal. So to give you a concrete example, a database client, my Redis client, will not have any async in it at all, because what it does is send a request, read a reply, send a request, read a reply. It's synchronous. It's first write a request, then read a reply, and et cetera, et cetera. And because of this, it doesn't need to do any async. Who might be interested in doing async might be at the above level, a user of my database client, where they say, we need to send these two commands, and for some reason, or now that is possible, but still kind of a weird use case. Let's say that we need to send a command to the database and also save a file on disk. And so, or like fetch a URL from the internet. And so you do these things in concurrently. So you call async on these things. But most libraries will not have to worry about any of this.
Yeah, that makes sense. So IO really becomes the end users, the end user being the Zig developer, building a project as opposed to a library. It really becomes their focus, their the thing they need to worry about.
Yeah, because I think that almost every single time it's like the application that decides what needs to happen in what order. Usually it's not libraries.
I do like the idea. So you mentioned the library, that the web server that needs to scale to 1 million concurrent users. I do like the idea that by supporting I/O, I could specify that I want a blocking I/O for maybe test purposes. So maybe
sure,
you could set up something in continuous integration that boots up a single threaded version and does one thing, like pings it with curl or something really nice and clean, which maybe you can make the case that doesn't actually reflect reality of how it'll be used and maybe is a bad test. But like the ability to, on a case-by-case basis, choose your implementation seems really, really nice.
For sure. And this ties not only to testing as in, like, let's say unit testing, but also ties to testing as in creating a I/O implementation for testing, which we don't know yet exactly how that's going to look like, but it's probably going to be something like for fuzz testing, where the idea is that we make an I/O implementation that schedules things in a deterministic manner based on a random seed. And so we try a few different, combinations of how things could run, and maybe we can use that to discover bugs in your concurrent code, for example. It won't be able to catch everything, but yes, that is something that makes total sense. I'll tell you one last thing related to this.
Sure.
Debugging. Have you ever tried to debug code that has async await in it? Let's say non-JavaScript code that has async await in it.
Not really. I had debugged some Kotlin coroutines when I was doing Android stuff, but outside of that, my debugging generally consists of aggressively putting print lines in there to track how the execution flows. So not using a pure debugger.
So here's the problem with Stackless Coroutines. You can build extra infrastructure to basically fake a better debugger experience. I'm saying fake, but it's what can I say? I don't mean that in a derogatory way. It's cool tooling. It makes total sense. But here's the core problem. If you, for example, took an old version of Zig and you wrote an async program with it and you try to debug it, here's what you would see. In a debugger, usually, you get in an error situation and then you do backtrace BT or something similar. You look at what is the path that got you there. So divided by 0 in this function. Okay, what happened? So you look at, and you can look at the call stack, and you can also navigate the call stack and see what was the state in that function, because maybe it turns out that you're dividing by 0 because somewhere in one particular case, you forgot to set a field, and so it defaulted to 0, and that's why you're dividing by 0, even though you're never supposed to divide by 0. So you can go up and see, oh yeah, here we did this thing, now it's 0 at this level, was not supposed to be 0, so the caller is where things went wrong, for example. If you try to do this with async, it's a disaster, because if you remember, I told you that async transforms functions into these state machines that you can basically poll for the next step of execution if you want. Now, whether you do polling or not depends on the execution model. In Rust, for example, it works that way, and people tend to assume that that's how secretly all async implementations work, but that is absolutely not true. That is one thing that is extremely specific to Rust. But they are kind of like generators, so they run step by step. So when you do the backtrace, here's what you see. You see that your application started, got into the main function, and the main function spawned a thread pool. And the thread pool, every thread in the thread pool is running the same function that looks at a list of pending tasks, grabs one, when the conditions are when it's ready to run again. I'm not explaining to you exactly what it is that makes a thing ready to run or not, but for simplicity, when a task is ready to run, grabs it and then runs it, and that's your async task. So your async functions. What is the problem? is that when you run an async function, it runs a little bit more, and then it gets returned to the queue of things that are waiting to be run again. And the OS thread that was running your thing now jumps back, returns into the main event loop worker function, where the worker keeps pulling for new, keeps pulling new jobs to run. Long story short, you have no idea what is your call stack because there is no call stack. At the end of the day, it's in name. They are stackless coroutines because there is no stack. And so debugging a program that uses stackless coroutines is a nightmare. Every single programming language that where you have some form of backtrace that is able to show you an actual stack, call stack is faking it. It's collecting this information not in the actual OS stack. It's doing extra work on the side to collect this information and track it for every, let's say, task that is running. So where am I going with this? Well, here's what you can do with Zig. Say that you have a program that you normally would want to run with stackless coroutines because you want to run this in WebAssembly, for example, and that's your only choice. If you want concurrency, well, what you can do is you can switch to green threads and debug it with green threads, and now you have stacks. Assuming that your bug survives this transformation. Obviously, if your bug is specific to what was going on with stackless coroutines, then the bug might not reproduce when you switch.
Man, that makes a lot of sense, and that sounds so nice. I was thinking about it, and I have had more experience with async await in other languages and debugging those too. Dart does an okay job, but I'm also curious if it ends up faking the stack trace like you were saying. One thing I am curious about, I don't feel like I see a ton of information in errors with Zig. Part of that, my understanding would be that we would have to allocate memory to work with strings in an error case, and maybe we don't necessarily want to allocate that memory, or we at least want to make it explicit. I guess I'm curious, do you imagine errors evolving to better support the async await use cases?
Errors.
Or error, like the error unions that we have, or like error handling, anything like that? Any changes to surface more information about what is actually going on when this error occurs?
So we would have to see. So I cannot speak with for certainty. So I'm going to answer first specifically with regards to async.
Sure.
And I cannot answer with full certainty because the implementation is not there yet. But I have a very strong feeling, I'm almost positive, that errors will actually work beautifully with async in this sense. Zig does this thing called error traces. I don't know if you ever noticed the difference between a stack trace and an error trace.
I'm not sure I've looked too closely, to be honest with you.
It's a difference that is not obvious. It took me a while to really understand exactly what these two things are specifically. But you said that you used Go, right?
Predominantly a Go dev, yes.
Okay. So I've used Go professionally for, I don't know, like a year and a half, couple years, a few years ago. So I'm guessing that you've also done the thing where you need to return an error. So you put a string in the error that explains what's going on, and then you bubble it up, and then at the upper level, you kind of do the same. Maybe not at every level, but occasionally at some points, you take an error, and then you add some context to it, right?
Yeah, you would wrap it with like fumpt.errorf or something, yeah.
Yeah. So you don't do this with Zig, partially because you cannot stuff strings inside of errors. But there's another reason. In Go, if you don't do this, you do not see where the error came from. Like, let's say that you bubble up some errors, but then at some point an error becomes a panic because something, let's say you're using something like .mast, like one of these things that panic in the case of the presence of an error. Mm-hmm. What you will see in the crash, it will tell you that, well, we panicked from this function and these were the calls above it.
Yep.
But what happened below?
Yeah, all the way back to the original source.
Yeah, you don't know what happened below. What's missing here is the error trace. So what Zig does is that every time in debug mode, whenever you return an error, you catch an error, you switch on an error, whenever you're doing error transformations, Zig writes somewhere else. So it is another one of those like do extra work on the side to obtain information that otherwise you wouldn't be able to obtain from the actual stack, the actual thread stack. So what it does is that every time you pass around an error, Zig remembers what happened. And so in Zig, if you have like functions that pass around errors, and then at some point as the error bubbles up, it turns into a panic, you will see the stack trace that begins from main and goes down to where it panicked, and then you see the error trace that starts from the panic and continues down to where the error was generated the first time.
So is the only way to get that information panicking? Like you have to force a panic with the error to get that information?
The error trace, technically no, because you have the ability with metaprogramming to obtain the error trace if you want, I believe. But in practice, it's a debugging. It's like debug information. It helps you understand what's going on. Like you as the developer helps you what's going on, but it's not meant to be seen by users much.
Yeah, I guess I was just thinking of a scenario where, like, let's say I build an exe in debug mode, I throw LLDB at it, and I'm hitting an error that I'm handling in my code because I'm a good defensive programmer, but I wasn't expecting to hit that error in this case. So like being able to look at the error trace in that case could be useful to figure out where it came from, even though I'm handling it. I'm not panicking. It's not a panic situation. But like maybe I'm trying to read a file and that file's not there, but I would expect it to be there. So I'm wanting to know like why, from a lower level, where that error is coming from.
I think that is a good question. I've never done it myself. I believe that you would be able to access that information in the same way that the panic function is able to access it. Like the panic function has some code to print the stack trace and some code to print the error trace. It's in the standard library, so you can literally copy paste whatever the panic function is doing, and you do it yourself whatever you want. That said, yes, it's not something that you can like trigger from the debugger currently, although there is a fork of LLDB made by Jacobly that is designed to support the new custom backends with more like Zig specific knowledge. And I cannot guarantee this, but it might be possible that this is something that could be made available in the debugger, but you need Zig specific knowledge in that case.
Sure.
I guess my recommendation would be like from a practical perspective, if you have a similar situation, drop a panic, look at the full trace, and then you go edit that. I don't think you can access that information more easily than that.
That's still really helpful. That honestly, one of my biggest gripes about Zig is I love the error handling, error unions, big fan of, way better than what Go does, in my opinion. But my gripe is that
you want payloads.
Yeah, exactly. Yeah, seeing the payload would be really helpful for debugging. So I still, what you said you do in Go, where you have to like trace the error down, I didn't know about the error traces. So I don't think I've ever written a panic function in Zig, mostly because Go teaches you not to panic. So my mentality is maybe I shouldn't panic. But that's really helpful because my gripe is with Zig, I have an error and I still have to trace that error all the way down. So what I've ended up doing is using extremely descriptive error names. So as soon as that error surfaces and I see that happen, I know exactly where to go in the code base to do that, which is an option maybe, but it doesn't always feel like the best option.
What I would suggest is, now that you know, maybe write a program where you can explicitly see in action. Like make a program that goes down like 3 functions, and then you have the middle one or like one intermediate one panic, and then see that you can see below the panic. Once you have that knowledge, I think that you don't need to make extremely descriptive error messages, because then you will be able to see the error trace, and you will be confident that you know where the error comes from. And by the way, you will see also like remappings. Whenever an error gets mapped to something else, you will also see that in the stack trace. Like you will see that, maybe error file not found becomes generic IO error at some point, assuming that you have this transformation somewhere. So I would say that with this knowledge, I think that you can make your programming more relaxed in that sense. Now, about payloads. This is not a completely closed question. So I believe that the question whether errors will ever have payloads or not is still open. If you had to bet money, you should bet money on them never having payloads, probably. But it is not guaranteed. That said, I will tell you my personal opinion, and I am a extremely strong believer of payloadless errors. So my reasoning is as follows. Errors are a nice tool for you, the programmer, knowing when a certain error condition happened and obtain a full trace of your program that is more complete than just a stack trace, because these are error traces that we just described. They are useful also because they're lightweight, and you can switch on them. You can roll back program state when you combine them with defer, which is nice. It's kind of like a transaction rollback in a sense. But them by themselves are, in my opinion, are not a tool for designing unhappy paths for your users. So, for example, let's say that you're writing a JSON parser, and in a program where you're parsing some JSON, at some point there's some kind of error. Now, what you want your user to know is which line, which column had the syntax error, or whatever the error is in the JSON. The user shouldn't care about what was your stack trace at the time, and it shouldn't know what was the error trace at the time. So while I understand that errors are in a sense, Zig errors are in a sense connected to the generic idea of errors in the program and unhappy paths, my argument is that a well-designed unhappy path requires you to program it explicitly using the same tools that you use also to program your happy path. So return values, optional pointers that you pass around. So are you familiar with the diagnostics pattern?
No, I'm not.
Okay, so the idea is this, and you will see that the standard library JSON parser does that. There's a library called Zig Clap. It's for command line parsing, also does that same thing.
Yeah, I've used
I do the same in my parser.
So
yeah.
my exposure is using the diagnostics in Clap at the very beginning after putting my string of flags into Clap, but no real exposure to diagnostics outside of that.
Okay, but the general idea is if you want more context on an error, then what you do is that you the caller, allocate some memory to make space for that error tracking, which could be just a struct on the stack, or maybe some diagnostics will require you to give them an allocator, because they do need to allocate memory, because the amount of errors that could happen is dynamic. Like they report more than one error at a time, so they might need to grow an array list, for example. So you create one of these things, and then you pass down a pointer to the parser function, for example. And the parser function accepts an optional pointer. So the idea is, if you want the extra information, you pass the pointer. If you don't, you pass null. And then the parser function, as it runs when it encounters an error, says, okay, did we receive a pointer to diagnostics? If so, we do the extra work to do the more precise error tracking. Otherwise, we don't. And we just return the error code. So we return, I don't know, parsing failure, whatever. I think this is a nice pattern, because it allows you to not pay for the cost of diagnostics when you don't need them, for example. Because, again, this is not maybe a huge deal, but let's say that you're doing JSON parsing, but it's in a pipeline where there is no human interaction anywhere. And so a parsing error is actually a programming error. Like this is not a condition that should happen. So you obviously do want to recognize that as an error and stop execution, panic, shut down, whatever, or I don't know, ignore a request, whatever your strategy needs to be. But this is not something that needs to surface information to a user. Knowing which line and which column might not be interesting, because, or I don't know, maybe it might be, but in debug mode, in normal operation, you shouldn't want to do that. this is the idea. But really, the performance aspect, I think, is secondary. The main perspective here is errors are not a tool for designing unhappy paths. You design unhappy paths the same way that you design happy paths, with types, return values, whatever you do normally.
Yeah, that's really interesting. I am so shocked I haven't thought of that yet. So just to reiterate, by passing the pointer, even though we're returning an error case, we can still manipulate that value in memory in the function so that the caller has extra information if they so choose to pass in that pointer. Man, okay, yeah, I really like that. I've been working on a project that's essentially an extension of the HTTP file specification that adds assertions to it. So you can write end-to-end tests with HTTP files. And I've been building it in Zig, and that was one of the questions I have not had a good solution to yet, which was, let's say some of the assertions pass, but one of the assertions fail. How do I indicate which ones failed? And that sounds like the pattern to do that. So I like that.
You will probably want a diagnostics struct that accepts an allocator and that internally grows an array list.
Cool. Yeah, I like that a lot. We're probably close to time. I know we didn't have a fixed time for this, but I don't want to take up your entire day. I did have two smaller questions, if you don't mind. They're a bit off topic, but like I mentioned earlier, I've been doing a lot in WASM. I was curious if we have a plan for what amount of the standard library is supposed to work in WASM. So, for example, the HTTP client doesn't because it depends on something POSIX related. I don't think JSON parsing works in WASM. At least I ran into an issue trying to get that to work, so I had to do like a JSON string builder on my own. And for context, I'm using Zig 014, not 014.1, not nightly, none of that stuff. So things may have changed.
I'm surprised that JSON doesn't work. I would imagine that if it doesn't, is probably because of some bug somewhere. I think it should work in WASM.
Okay.
Let me think about it for a second, but I also am fairly confident that somewhere, somehow, it can work, because I have a language server for HTML. So as part of my static site generator, the bigger ecosystem around it, I wrote what is apparently the first ever language server for HTML, surprisingly enough. And the way it works for VS Code is that I build the language server in WebAssembly, and I bundle it with the VS Code extension. So you you install the VS Code extension in VS Code, and it immediately works because it runs internally. Since VS Code is like Node and it has also a WebAssembly runtime, it just runs the language server in WebAssembly. And language servers speak JSON RPC. So JSON parsing and marshalling, stringifying, whatever it is, also happens in WebAssembly. So
maybe I did something wrong, and maybe my homework from this should be to try one of the nightly builds and see if it works with the nightly build, and if not, file a bug report.
Yeah, maybe. Also because, in any case, this is a good time to do this, because 0.15 will be released in like a week or two from now. So we're there. Yeah. As for other things, HTTP client, you are probably right. Although it should be noted that, yes, HTTP client, like if you want to do an HTTP request, then yes, you need the ability to open a connection. And WASM by itself doesn't have that. So maybe it would work with WASI. So if you target WASM WASI, but I'm not sure. That said, I can tell you that all of these things are being rewritten. So I don't know if maybe in the future you will be able to basically attach a HTTP client to a stream that you somehow initiated from, I don't know, JavaScript or whatever runtime you have around your WebAssembly application. The reason why I'm saying this is because, for example, the HTTP server is completely connection unaware. I don't know if you looked at it, but it's really neat. It's just a parser. So you create a connection, and then you let the HTTP server read from that connection. And every time it reads a request, it tells you, you receive a request object, and then you decide what to do with it. Like spawn a new thread to like detach that connection. For example, you have a WebSocket upgrade request, so you can spawn a new thread, detach that connection from the HTTP server, and then do something else with it or not. So long story short, it's just a parser, and so there is no reason for it not to work in WebAssembly. But to conclude, as for what should or should not work in WebAssembly, the idea is, in general, is that everything that can work should work. What that exactly looks like, I think it's not formalized anywhere, because the standard library right now is not the focus of development. So people tend to basically contribute changes, additions, and bug fixes based on them trying to unblock themselves when they try to do something. That said, WebAssembly and HTTP are now becoming more central, because I don't know if you saw it, but there's a command called you can do Zig STD, and it builds and runs locally a web server to serve standard library docs from your computer. So you can access the online ones, but you can also run them locally. Similarly, there is a new feature that MLAG added recently called, it's the time report. I don't remember what is the flag to turn it on, but when you do, it opens a web server that sees your build process running. It collects timing information for all the build processes, and then it also gives you information about how long it took to analyze and compile parts of your program. So, for example, it tells you, you can also use it to know how many generic instantiations you have of a given function, which sometimes could be nice, because maybe you made something comp time and you didn't realize that, oops, now you're making 100,000 copies of it. Slightly different, right, based on the comp time parameter. And lastly, fuzzing also has a web interface. So fuzzing is far from ready at the moment, but this is also another huge thing coming to Zig. And fuzzing basically it will run a fuzzer, but then you will also have a web interface where you can see, for example, your source code, and you will see tiny dots next to points in your source code that the fuzzer knows it can hit. And because the fuzzer is code coverage guided, so it will have knowledge about which parts of your program it was able to trigger or not with any given random input, and it can use that information to make progress. And you, as the programmer, can say, yeah, you know what, I really want to see it fuzz this function. Is it ever even able to enter this function? And so you can see that from the interface.
Man, that sounds really nice. I love fuzzing in Go. I've used it a lot. I'm mostly developing on a MacBook, so I've not used fuzzing in Zig yet. I know I could throw it in a VM and let it run on Linux or something, but
yeah, well, the Linux one is also, so the Mac one is broken. We made some fixes for it that MLAG has on his computer that he has not upstreamed yet. We were actually talking about this yesterday. But even the Linux one is not ready for prime time. Today, the best way to get fuzzing is to use AFL. I have a library for this called Zig AFL Kit. That said, I said that it's best. That does not mean that it's good, because unfortunately, LLVM 19 and I suspect also 20. I know for a fact 19. I suspect also 20. They regressed AFL horribly. So basically, when you want to use AFL, it's going to be LLVM who basically provides information about the program to the fuzzer. More specifically, it's going to be LLVM that does instrumentation of the executable. When you use the Zig native stuff, it's not going to be LLVM. And so that's why it's not regressed. But basically, AFL, to me, from my perspective, has been broken since LLVM 19. So you'll have to wait for the full Zig fuzzing.
Yeah, that's fine. I'm just appreciative that Zig as a language platform is shipping fuzzing. That seems like a nice thing for the language to take control of and to be able to do a great job with, because of everything that the compiler itself is aware of.
Yeah, absolutely. And also, when I think about my projects, right now, good I/O and fuzzing are the only two blockers that I have. Once those things will be in place, I think that really all my projects, it's going to be entirely up to me to make them better. There's not going to be an excuse anymore. More specifically, I have a well, my parsers, for example, I wrote my HTML language server and I have my own HTML parser. And I don't use the label switch syntax, which was added recently.
Yeah.
And that makes a huge difference in performance. But I don't trust myself to make the transformation without introducing bugs. So what I'm doing is that I'm waiting for fuzzing to come into Zig so that I can use the original implementation as a oracle and then fuzz the new implementation against the old one and see if they ever disagree. And I'm going to use that to catch bugs.
That's a really good idea. I had very mixed opinions of labeled switch at first. And actually put out a YouTube video about that, and people came out of the woodworks to tell me I was wrong, which is, it's always a great sign to have that happen. But they were right; they totally were. I started using it more. It felt like go-tos, and I again, just from my background, go-tos always felt bad. But after using it more, I don't feel that way at all. So my first impression was a little rough, and thankfully the community came out to tell me I was wrong, and they were right. So.
I think it's fair to say that there's one funky thing about label switches, which is that they are while loops, and you don't see the keyword while, so you might not realize that they're looping. Although once you see a switch that has a label in front of it, you can start suspecting that that's what's happening. But here's one. So you're starting to use them. Are you using them for parsers? Are you talking about your HTTP file?
Just parsers,
program? Yeah. Okay. So here's one technique that I've started using that I find amazing. Remove fall off from your switch cases completely. So you know how sometimes you have a switch and then the switch case ends and then you fall off the switch entirely. While I was porting my stuff, I realized that it's much easier to reason about what's going on and to prevent bugs consequently if you make sure that at the end of every case, you either explicitly break from the switch or continue looping into it.
Yeah, that makes a lot of sense. That explicitness makes it easier to follow. I don't think I think I am doing that in every case. I tend to err on the side of write more code if it's more explicit instead of letting things be implicit. I think that actually was part of my gripe with labeled switch. You mentioned it's a while loop under the hood. It doesn't look like a while loop under the hood. It doesn't feel explicit.
Yeah.
And I think Zig generally tends to be pretty explicit, which I like. But yeah, I if I'm not doing that, I will definitely swap that over. It definitely seems easier to reason with.
Yeah, in this case for the switch, it makes sense because it really improves code generation. Like you can express things that you just cannot express with a while loop over a switch. And so that's why for my tokenizer, for example, it made like a 60% performance increase, which is huge. It's small in the grand scheme of things because tokenizing it doesn't take a lot of time compared to what programs do normally. But still, within just the scope of tokenizing, it was huge. Last trick related to this. So here's how I structure my tokenizer. It's a switch. It's a label switch. It either continues into another case, or it returns from the function with the new token, and it never falls through. To guarantee that you never have falling through, because when I did this on stream, I didn't notice that somewhere I had an if without an else case, and that was causing me to fall off the switch by mistake. To guarantee at comp time that this doesn't happen, so you get a build error, a compile error if you forget something, you can add afterwards comp time unreachable. So you have your label switch, and then below it, you do comp time unreachable. And it's guaranteed that you can't exit it unless you return from the function.
Yeah, that is brilliant. Okay, I need to try that. I honestly, my exposure to using comp time outside of your standard uses for comp time is pretty limited. So I should probably explore that more because that sounds like a really, really great use case.
Yeah. If I remembered about this when I was doing the work on Twitch, I would have saved myself 10 minutes of pain.
Was this for Zine or something else?
Yeah, for Zine. It was the tokenizer for one of the languages related to Zine. I want to port everything else, also the parsers. The problem is that, as I said, I'm waiting for fuzzing because I'm guaranteed to cause regressions otherwise.
Yeah, that makes sense. Okay, well, I think we're pretty close to time. So thank you for taking the time to chat with me and spread the great word of Zig. Really appreciate the deep dive into I/O. It's something that I started with Zig 13, things changed pretty drastically with 14. Things seem like they're changing pretty drastically with 15. All for the better, but it's always nice to have the experts kind of guide us through that. So thank you again.
No problem. Thank you.
Well, that's the conversation. I hope you found it as enjoyable as I did. And if you haven't yet, don't forget you can subscribe to the channel for more information on Zig and plenty of learning opportunities, as well as the opportunity to hang out with the little tiny community that we've been building on our little corner of the internet. On that note, there's also a link to the channel's Discord in the description below. And I'm also going to put the Zig Showtime channel in the description as well. That's Loris's channel, where he does live streaming on all things Zig and has been building out all sorts of really cool things, some of which we've talked about in the conversation that you've just heard. If you appreciate the video, give it a thumbs up. It helps me, it helps the algorithm, and ultimately I think that helps you too. I think that's it, so thank you and have a great day.